Solving linear equations beyond the basics 3. So let's recall a linear equation is an equation whose highest power of the variable is 1, and there's no variables in the denominator or bottom. So in Beyond the Basics 3, we'll focus on linear equations with a fraction and at least one term, but no variable in the denominator. This may require techniques learned in the Basics video or Beyond the Basics 1 and 2. So if you need to go back and watch those, you can. This is also covered in my Solving Rational Equations video, where I also discuss what to do when you have variables in the denominator, which we're not discussing here. Okay, so if you need that, then there's your video there to go find, and you can see that. All right. So when I have an equation with fractions, I choose to multiply every term on both sides by the LCD first and then solve. That's my eliminate fractions that I talk about when I solve equations. I always like to eliminate my fractions as soon as possible. So then once you do that, simplify both sides, move all the variables one side, numbers to the other. When I say numbers, I'm talking about constants. And again, if you need more help with this, if you need something more basic, go to the basics or my Beyond the Basics videos 1 and 2. All right. So here, x over 2 equals plus 13, equals negative 22. And then check it. And again, check it. I say go plugging in the original, that kind of thing. All right, talk more about that when we get there. Let me preface this. There is a shorter, maybe you would say a shorter, easier way to work this problem. But here's the problem. I talk about recognition all the time. Students come in and they try to do things, and one of the things that students will do in this section particularly is they'll try to cross multiply, and they do it wrong. I've taught 68 semesters roughly in my career, and every single semester, 68 out of 68, someone has tried to use cross multiply incorrectly. So teachers out there, if you see this, just don't teach it anymore. You and I know when to use it because we're good with math. Cross multiply is super easy. Oh my gosh, it's so easy. But you know what's hard about cross multiply? The student knowing when they can do it and when they can't do it. That's what's hard about cross multiply, and that's why 68 out of 68 semesters I have students do it wrong, because they hope desperately the problem is easy and they remember cross multiply and it's easy, so they try to apply it and it doesn't work. In the wrong scenario. When it works, it's great. It's short. This particular problem, not set up for it as it stands, but this particular problem can be done shorter than this. But listen, I like ways that always work. Always work. And multiplying the LCD by everything always works. Now, I am going to skip a step, and we'll talk about that as we go through here. So let's see, what is my LCD? Well, if I look at this problem, I only have one denominator because these things are over 1, so that doesn't count as denominators, and worry about LCD. They are denominators, but don't count in the LCD. The only denominator I have is 2, so guess what? My LCD must be 2. So what I'm really doing, I'm going back to a very basic axiom or property of mathematics. If I multiply one side of the equation by 2, guess what I got to do the other side? Multiply by 2. So if I multiply both sides by 2, 2 over here and 2 over here, okay? And it doesn't matter if you write it on the right or the left. I'm multiplying by 2. If I do that, what am I going to do with this 2 over here? I'm going to distribute it. So that's when I say multiply every term on both sides, I'm going straight to the distribution step. I am skipping writing it down in parentheses. You won't actually see me write down this, and I don't like to change the original very much and do much to it. So I'm going to leave that there. I'm going to come down here and say 2 times the first term plus 2 times the second term equals 2 times this term. So I did 2 times every term, and I showed this distribution. That's this term, and that's this term, okay? I'm showing the distribution, I call it, all right? So there, 2 times everything. And when I do that, something very nice happens. When I multiply everything on both sides by the LCD, I eliminate my fractions in one step. If that doesn't get a glory hallelujah, nothing's going to get it, okay? Because nobody I know goes, ooh, I love fractions. Math teachers don't even love fractions. If they tell you they do, they're crazy. They don't love fractions. People don't like fractions. I can do fractions. I'm fine. I don't have any trouble doing problems with fractions in them. Doesn't mean I like it. Nobody like fractions. All right, so look. We're going to eliminate fractions. That's why we get rid of them. Sorry, fractions. I'm not trying to hurt your feelings. All right. But that's why we're going to get rid of them. So then here the 2 is over 1. Don't forget that. That way these 2's divide out and I'm left with what? Just 1's here. And that's nice because I get x over 1 and I don't write anything over 1 ever. I just write down what? X plus 2 times 13 is 26 equals 2 times negative 22 is negative 44. And then I get this wonderful blue equation here. And the reason it's wonderful is not because it's blue, it's because there ain't no fractions. Okay? If you don't speak ain't, there's not any fractions there. Okay? So there's no fractions. Now, how do I solve this one? Well, guess what? The negative 44 is by itself, so I need to move the 26. So let me subtract it from both sides. That cancels. We get x equals 2 negatives. You're going to add them together and keep it negative. And look, when I do this in my head, I don't do 4 plus 6 and carry a 1. I do 40 and 20 is 60, and 4 and 6 is 10. 60 and 10 is 70. That's how I think about it in my head. Okay? So negative 70. Negative 70 is my final answer here. And then it says check. And again, for me to check, I want you to go in the original equation, and I always put parentheses here. That's too small. Negative 70, that's my x, over 2 plus 13 equals negative 22. All right? So I plug it in. I always plug it in with parentheses around it. So I don't need it, the parentheses here, but I just always put it when I'm plugging it in. Negative 70 over 2 is negative 35 plus 13. So let's keep simplifying this side. Negative 35 plus 13. Subtract them. 35 minus 13 is 22. The sign of the larger is negative. And then on the other side, there's nothing to do. Just bring down the negative 22. Does negative 22 equal negative 22? Check. It's good. It's good. I checked it. That's what I want you to do in my class. If you're checking it, I want you to do that. Okay? Show me that. I have to see it. You can't. I checked it in my head. No, I don't know. Whatever. No. I got to see the work. I ask you to check it. You got to show me the work. So if I don't ask you to check it, then if you show that, that's fine. If you don't, that's fine too. All right? It's always a good idea to check your answer, but if you're told to check it, you need to show it, not just do it in your head or go back through it or whatever. All right? So this problem would have been better suited to move the 13 first and then do something, multiply by the 2 or whatever. But again, if I have fractions in an equation or a fraction in an equation or an inequality, the less thans, the greater thans, I always multiply both sides by the LCD every term and eliminate my fractions right off the bat. And that ought to make me happy because I don't want to do. Now, I might get a fraction as an answer, but I didn't deal with it the whole way through. So this is maybe different than how you're used to or were taught or whatever, but that's just the way I handle it. So here, k plus 5/8 equals 7/8. So when I look at this, I have 2 denominators. And but the good thing is they're the same. So what is my LCD here? It's 8. So remember, if I multiply 8 times everything on the left, I'm really multiplying 8 times 2 terms and distributing, right? So that means I have 8 times the k plus 8 times the fraction 5/8 equals, on the other side, 8 times the 7/8, and there's nothing else to multiply 8 by on the right-hand side. So 8 times all 3 terms, 2 on the left, 1 on the right, because I'm going to distribute the 8. I'm just skipping the distribution step, going straight to it. It's going to be this way every time. I do this every time I have an equation with a fraction in it. Every single time. It always works. Even if something else works. That way I don't have to think, oh, Mr. Yes, it works. I can do it in this scenario and this. No, it always works. You don't have to recognize and remember when this happens or when that. He cross multiply, you have to know when it works and when it doesn't. And that's much harder than actually cross multiplying. That's why in 22 years I've never taught cross multiplying. I don't plan on ever doing it. Because this way always works. Now, once you work 30 of these, 40 of these, you do all your homework, whatever, and you begin to see patterns and you notice things, then you can start using cross-multiplying in some special cases. But that's because you've discovered it. You've seen it. Now it makes sense to you. We teach it backwards. We teach all these special things and then say, oh, go have fun. No. So multiply by 8. 8 times k is 8k. Here, 8's over 1. That's important because these 8's divide out and I'm left with what? Plus 5. That becomes a 1. So 1 times 5 is 5. Okay, and if you want to say that's a 1 too, 5 over 1 is 5. And then equals, here, this is also over 1. So I didn't put this 8 over 1 because it's not times a fraction, right? K is not a fraction. But the other ones are times fractions. I always remind myself that that LCD is over 1. So again, the 8's divide out and I'm equal what? 7. And look, that gray equation is beautiful. Because there's no fractions. There's no glory, hallelujah, there's no fractions. Okay? There is no fractions. So guess what? I'm going to then move what? I'm going to move the 5 because the 7 is by itself. That's how I know what to move. I look at the thing by itself. I don't memorize My teacher just said move this. No, look at what's by itself. The 7, move the 5. Subtract 5 from both sides. The 5 minus 5 cancels. 8k equals 7 minus 5 is 2. 8k equals 2. And then finally, I divide both sides by the coefficient. It's multiplied by the variable k. Divide it to undo it. K equals, now be careful, this is not 4. What goes into 2 and 8? 2. How many times does 2 go into 2? Once. The 1 is in the top, the numerator. So this becomes a 1, and this is a 4. So this is 1/4. So k equals 1/4. So 1/4 plus 5/8 is 7/8, and 1/4 is 2/8, right? So 2/8 plus 5/8 is 7/8. 1/4 and 2/8 are what they call equivalent fractions, right? So g plus 2/3 equals negative 7/6. Now here we go. Now we're getting a little more complicated because now we have two denominators and they're not the same thing. So we got to find our LCD. Now the way we find LCDs is we take the largest one when it's numbers. When it's variables, we have to have the highest power. But when it's numbers, we don't have variables in this video here. This is just numbers. When it's numbers, you take the largest one, 6, and you say to all the other denominators, in this case there's only 3, the number 3, I mean there's only one more. Does 3 go into 6? Yes. So then 6 is the LCD. If 3 did not go into 6, you would take multiples of 6, 6, 12, 18, 24, until all the other denominators divided into that number, and then that will be your LCD. So here, my LCD is 6 because 3 goes into 6. Okay, I can use orange. I thought I'd used it on the last page. LCD is 6. So then I multiply 6 times both sides, which is distributing to the left-hand side. So I'm going to say 6 times G plus 6 times 2/3. I'm just going to show it. I'm going to skip the step where I write it all in parentheses times 6. Every term times 6 equals 6 times negative 7/6. Now, if you wanted to do negative 6, the negative sign, however you did that, that's fine. Okay? I'm going to do 6 times negative 7/6 there. Okay? If that negative 7/6 followed another term, not the equal sign, then I would put minus 6 times that or whatever. So here, 6 times negative 7/6. So here, 6 times G is what? That's good old 6G, right? And then here, 6 is over 1. I did that because I'm multiplying 6 times a fraction, right? I'm reminding myself, hey, that 6 is in the numerator. It's up top. So this 6 and 3 divide out. This is a 2 and a 1, right? A 2 and a 1. So now I'm left with plus 2 times 2. What is positive 2 times 2? It's plus 4, right? I'm taking all that together, multiplying. And then here equals, this is over 1, 6 and 6 divide out. They become 1s. If I don't write anything, we just understood to be a 1 there. So, but it's not a bad habit to get in to write the number every time, even if it's 1s. Okay? So then now I have a positive times a negative, which is negative. And then 1 times 7 is 7 over 1. But do I write over 1? No, don't write over 1. Just put minus 7. You don't ever write over 1. The other one's 4 over 1. You don't write it. You just write 4. Okay? So 6G plus 4 equals negative 7. And then I need to subtract 4 because the negative 7 is by itself. So 6G equals negative 11. And then what do? I divide both sides by 6. And I get G equals negative 11 over 6. G equals negative 11 over 6. And by the way, if I were checking this one, if I were told to check this one, I would put my negative 6 over 11 in for G, and because I have fractions in it, I'm going to multiply by the LCD first step on both sides to eliminate my fractions. That's what I'm going to do. All right? If they don't allow you to do that, then get your common denominator. But I mean, if I do that and I get this number equals this number and I get 4 equals 4, I just put 4 over 6 equals 4 over 6. Okay, it worked out. Because when you multiply by the LCD, you're just getting rid of the denominator, so you can go back and put anything in if you need to. All right? So negative 1 over 8 plus R equals negative 1 over 4. So again, we have multiple denominators here, 8 and 4. Which one's bigger? 8. Does 4 divide into 8 or go into 8? Yes. So my LCD here is just what? 8. So I'm going to multiply 8 times everything. 8 times negative 1/8 plus 8 times r equals 8 times negative 1/4. Eight times negative 1/8 plus 8 times r equals 8 times negative 1/4. So I'm going to remind myself 8's over 1 when it's times a fraction, and these 8's divide out, they become 1s. That whole thing becomes what? Negative 1, right? 1 times 1 over 1 times 1 is 1, with a positive and a negative is negative when you multiply. So the whole thing is negative 1. And then plus, I'm not going to put that over anything because it's just times r, so it's plus 8r equals 8 is over 1 here, and that becomes what? 2 over 1. So then 2 times 1 is 2 over 1, so it's 2, and then it's a positive times a negative, so it's what? Negative. So that's negative 1 plus 8r equals negative 2, and that's great because now I don't have any fractions. Every single time I multiply everything by the LCD, I eliminate my fractions completely. If I don't, I messed up, either in choosing my LCD or when I try to get rid of my fractions. But that's a glory hallelujah moment because there's no more fractions. So now the thing by itself is negative 2. Add 1 to both sides to get rid of the negative 1 on the left. So 8r equals what? Negative 1. And then we divide both sides by 8. And we get r equals, now if the entire numerator or denominator of a fraction is negative, you can just bring the negative out front. Negative 1/8. So r equals negative 1/8. All right. 3m over 4 minus 2/3 equals 7 over 12. All right, well, we have 3 denominators. We have 4, 3, and 12. What's the biggest one? 12. Does 4 go into 12? Yes. Does 3 go into 12? Yes. You think it'll always be yes? No, it won't always be yes, but here it is. So my LCD is what? It's 12. Well, that's nice. So then I say 12 times 3m over 4 minus 12 times 2/3. Why do I go straight to the step? Because I've got to distribute to all those terms anyway, right? So why not just go ahead and jump straight to that step? Boom. And save myself a step. Equals what? Don't forget 12 times everything. Even if it was a whole number 7 over there, you still multiply everything by 12. It just so happens all of these are fractions. And I even exaggerated and wrote my 12 so high you could tell it's in the top or the numerator, right? I'm going to go back and remind myself they're all over 1 because they're all times a fraction. 12 over 4 becomes what? 3 over 1, right? So if everything down here is a 1, you don't have a fraction anymore. That's the whole point, okay? So then 3 times 3m up here, what is that going to be? That's 9m. Don't get confused and add those. That's 9m. And then a negative times positive is negative, right? So I got a minus. 12 over 3 becomes a 4, right? 4. And that's a 1. So again, that's nothing down there. No denominator left. 4 times 2 is what? 8. So 9m minus 8 equals, and over here, 12 and 12 become 1s. So they're, in essence, gone as far as multiply and divide goes. If you multiply by 1, it doesn't change. Divide by 1, it doesn't change. So what does the right-hand side become? Good old 7. 1 times 7 over 1 times 1. Now the 7 is by itself, so what should I move? The 9m or the negative 8? The negative 8. Right? How do I move the negative 8? I add it to both sides. That cancels. I get 9m equals 15. And then what do? I divide both sides by 9. M equals 15 over 9. And that then simplifies to what? What goes into both those? 3. So it's going to be 5. 3 goes into 15 5 times. 3 goes into 9 3 times. So my m simplifies to what? 5 over 3. Just realized I did an extra step there. I could have said 5 over 3 here, right? So m equals 5 over 3 or 5/3. 1 and 2/3, right? But leave it 5/3. Don't write mixed numbers in algebra. Unless your teacher says to. Always check with your teacher on what they want. Don't say, oh, that crazy guy on YouTube does this. Who cares? Your teacher doesn't care what I do. Okay? Now they care in the sense that if it helps you learn, then that's good. They're going to care about that. But they're not going to care that I do this and mix numbers and don't do it and they do or whatever. So W over 4 minus W over 5 equals 1. I have multiple denominators, 4 and 5. What's my LCD? Well, which one's bigger? 5. Does 4 go into 5? Nope. So then 5 is not my LCD. So when I'm looking for my LCD, it ain't 5. So then I do what? Multiples of 5. That's 5. 5 times 2, 5 times 3, 5 times 4. So I'll do 5, 10, 15, 20, 25, 30, 35, 40, right? So does 4 go into 10? Nope. What's next? 15? 5, 10, 15. Does 4 go into 15? Nope. 5, 10, 15, 20. Does 4 go into 20? Yes. And 4 is the only other denominator, so 20 is my LCD. So now I need to multiply everything on both sides by what? 20. I don't know what I just wrote that for. That's W over 4, not 4 over something. And then minus 20 times W over 5. And again, I'm skipping the step where I show the distribution, right, with the 20 times the parentheses. I'm just doing 20 times the first term, 20 times the second term, 20, whatever the next term is, equals. Now look, this is not a fraction over here, but you still multiply that 1 by 20. That's the LCD. Everything gets multiplied by the LCD or you're going to mess it up. It's got to all be multiplied. So then I'm going to put 20 over 1. I'm not going to do that over here because this is not a fraction, right? So don't put that side over 1. So then 20 over 4, right? Anything in the numerator, denominator, top and bottom can divide out if they're multiplied. These are multiplied. 20 over 4. 4 goes into 25 times and 1 time into itself. So that thing becomes what? 5W over 1, which we don't write over 1. So 5W. The next term, minus 20, and then let's see, 20, let's see, it's minus, right? Negative times positive, 20 and 5. How many times does 5 go into 20? 4 times in itself once. So that's minus 4W equals, what is 20 times 1? 20. And then a glorious thing happens. What's 5W minus 4W when you simplify? 5W minus 4W is just good old W. So W equals 20, and there's nothing to divide by, you're done. W equals 20. W equals 20. So P over 12 plus 1 over 6 equals P over 2 minus 1 over 4. So now I have 4 fractions. What's the largest denominator? 12. Does 6 go into 12? Yep. Does 2 go into 12? Yep. Does 4 go into 12? Yep. So what's my LCD? 12. 12 indeed. So then I'm going to take 12 and multiply it by everything. 12 times P over 12 plus 12 times what? 1/6. Right? I would normally show that with parentheses around everything, but I'm going to get to this step. I'm going to distribute, right? So guess what? On the right-hand side, do the same thing. Equals 12 times P over 2. Just go ahead and show the distribution right off the bat. Minus 12 times 1/4. They're all multiplied by fractions, so I need to remind myself that all of the 12s are over what? 1. And then we start with the first term. 12 over 12 becomes what? 1 and 1. That whole term becomes what? Just a good old P. P plus. Plus what? Well, 12 over 6 becomes what? 2 over 1. So then this whole term becomes 2 times 1 is 2, and then over 1 doesn't matter, right? Over 1 we don't write. Equals 12 over 2 is what? 6 and then 1. So then 6 times P is 6P. And then minus what? 12 over 4 is 3. So then minus 3 times 1 is 3 over 1, right? That doesn't change when it's over 1. So look at that beautiful blue equation. There's no fractions. None. Not a fraction. So you can move anything you want to move, all right? And I've always put my variables on the left in all my videos so far. I'm going to do that different this time just because you can. I'm going to move P this time. I'm going to subtract P. And if I do that, that cancels. I get 2 equals 5P minus 3. Now really, at this point, I want you to be able to do both steps at once. If you move the P, I want you to also move the negative 3 at the same time. But if you get confused, don't. Take it one step at a time, all right? So then here, now the best move is to move the negative 3 over by adding it to both sides. So that cancels over there. We get 5 equals 5P, okay? And then what do? I divide both sides by 5. That divides out. That becomes 1 over 1, so that becomes 1 equals P. 1 equals P. H minus 2 over 3 minus 4 equals H plus 1 over 4. Here I have how many fractions? 2. Now the thing that's different about this one is now my numerators have multiple terms. Yay, right? So my two denominators are 4 and 3. So the bigger one's 4. So to find my LCD, does 3 go into 4? Nope. I take multiples of 4. 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 20, 24, 28, 32, 36, right? What's the first one that 3 goes into? That's right, 12. It doesn't go into 8, it goes into 12. So then my LCD is 12, and you look at this, you go, okay, 12 times H minus 2 over 3 minus, don't forget the 12 times the 4, equals 12 times this side, H plus 1 over 4. So for this first one, 12 is over 1. 12 over 3 becomes what? 4, and that becomes a 1. The whole point is to make that 1 in the bottom in the denominator. So now, this is the step I want you to write down. 4 times, many of you will do this in your head, and if you get it right, that's fine. The problem comes in when there's a minus sign in front of that. That's where people really start to get confused and make careless mistakes. So that's why I suggest writing down 4 parentheses H minus 2 in case that was a negative 4. That negative 4 is what will get you. So minus 12 times 4 is 48, right? If I put those together, I get 48. And then equals, this is over 1 again, it's times a fraction. I didn't put this over 1 because it's not a fraction, right? So don't do that. So then 12 over 4 is 3, so this is going to be 3. That's an ugly 3, let me fix it. So it's going to be 3, not that any of my writing is neat, but anyway. 3 times H plus 1 in parentheses. So now, this nice pink, fuchsia, whatever color you want to say here. Excellent equation because there's no fractions. There's none. No fractions. It always thrills my soul. Get rid of those fractions. Sorry, fractions. So then here we're going to distribute. We're going to say this is 4h minus 8 minus 48 equals, right? Because we got work to do on the left-hand side. Not worried about the right-hand side right now. Just do the left-hand side. And then over here, I can say, okay, this is going to be, put those together, 4h. 2 negatives means it's going to stay negative, and you add them together. 8 plus 48 is 56 equals, and then we come over here. We got to distribute the 3. We get 3h plus 3, and guess what? There's nothing else to do that, so just bring it down. And again, if the left-hand side had been 6 more steps, bring it down 6 more times, or I would let you draw an arrow through all 6 and just write it down once at the bottom, but your teacher makes sure you do what they want you to do. So then I'm going to move. Now I have a best move. You can move anything here. It's okay. It'll work, but you can save yourself one step if you notice that 4h and 3h are 1 apart. So move the smaller one. Move the smaller one. If I move the 3h over, that cancels. I get h minus 56 equals 3. And then the best move is to add 56, and because I moved the one that was 1 smaller, I don't have a coefficient of h to divide by. H is just simply what? 59. And that is glorious. Right? And I saved a step because I chose to move the 3h because I noticed 3h was 1 less than 4h. If they're 1 apart, move the lower one. It will always save you 1 step. All right, so I hope this has helped out. This is pretty intense here with these fractions, but I always multiply every term on both sides by the LCD when I am solving